Hello, this is problem 8-63 for lesson 8.2.1 for integrated math 3 CPM. If you are given roots of a polynomial, we are going to write the equation that has these roots, and we're going to be writing a possible equation. Without having another point that the curve passes through, we cannot write an exact and unique equation without another point to find, for example, a stretch factor. So this equation that we will write will be a possible equation that does have these roots. And so the first one that we'll start with here is when you're given real roots. Again, this is a real number. It happens to be a fraction, but it's 3/4 and -5. My preferred method is to start by thinking about working backwards often. And so I like to say, well, if these are roots, then these were really x equals 3/4 and x equals -5 that were the roots of this quadratic. And if I'm thinking about using zero product property and working backwards, then this is the same thing as x minus 3/4 equals 0 as one of the linear factors. And for the other one, it would be x plus 5 that would equal 0. And then I could put both of these together into one equation, and that equation would represent a possible quadratic in factored form. However, I wanted to point out that we almost never see x minus 3/4 as a linear factor. And the reason why is really I could think about that more than likely this could have started something that looked a little bit like this. If I multiply this side by 4 and this side by 4, this linear factor then becomes 4x minus 3 equals 0. And that has the exact same root, 3/4, as what I have above. And so most likely it would have started with something like that or something similar to that. So let's say y equals, I mean similar as in by a multiple of that value. Y equals 4x minus 3 times x plus 5. And so that is a factored form equation that would have those particular roots.